logistics came in sync over here. All right, y'all. We have a couple housekeeping items that we're going to jump into everything. We have 4 talks scheduled for tonight. I want to hold it, but I know as soon as I hold it, it's going to start making a ton of noise, right? No. I got rough hands, man. Okay. Just quick show of hands. How many people, it's your first time ever coming out to a DSD meetup? All right. Well, we've been doing meetups for 2 years. Where y'all been? Thank you so much for being here. You could be anywhere in the city of Dallas. You decide to hang out with us. That really means a lot to me, and I'm hoping to make sure that we honor your time. I'm a very big believer in value for time, and I'm hoping that you get that tonight. We have 4 talks, so we're definitely making sure that you get like a range and variety of topics. We have some speakers, 2 in particular, that literally drove from Austin to speak here tonight. So huge kudos to them, and like really, really appreciate them even being here. So a round of applause for them, please. Kierra and Satinder. Absolutely. If you've never been to a DSD meetup, let me kind of set the tone a little bit. This is Dallas Software Developers. We are a community of developers. We do a wide range of topics. We try to do meetups at least twice a month. Sometimes it goes over that, but generally twice a month is like a good barometer for when we're doing events. And we also just did the Commit Your Code conference. Just show of hands, how many people did not go to Commit Your Code? I know, see, I got so excited. All right, Commit Your Code, for those that aren't aware, it was a tech conference for charity that we do. The idea is that it's a $700 conference for $49. We donate 100% of the money. We ended up raising over $24,000 for charity, which was all donated. Huge, huge success as far as I'm concerned. We had the official numbers are 8,100 online, 860 in person. I think that's a huge win. We really knocked it out of the park. And so we're definitely bringing it back this year. We're figuring that out right now as we speak. But generally speaking, we're probably going to still do it in the Plano area. So maybe keep that on your radar for around September, October-ish. We'll have official dates announced on the Discord, the website, of course, and on Meetup. So make sure, like, if you're not following us on Meetup, fix that. If you're in the Dallas area and you're not on the Discord, highly recommend checking that out. If you want to get any of those links, go check out our website. Also, if you want to commit to an open source project, check out our website. It is open source. This is version 2 of our website, which we kind of elevated and we're still finessing, but I mean, there's a ton of stuff there. Now, one thing in particular, I've been asked repeatedly, probably in the last several weeks, one thing that we do at DSD is a cohort program. The cohort is 100% free. If you notice that DSD is completely volunteer ran and driven, we do not monetize in any way, shape, or form. We have a couple of leaders in the house tonight, so I want to give a huge shout out to my brother over here, Dennis Garcia, please. I see Dennis and Eric over here on the side. Shout outs to them. I don't see Clinton Myers, but if he's here, kudos to Clint. If not, he's always here, so he deserves a day off every now and again too. So Clinton Myers as well. Absolutely. We're nothing without the people that volunteer their time, so kudos to y'all. And of course, thanks to me. I'm just saying. But one of the things that we do in DSD is the cohort program. And I've been asked repeatedly, when are we doing the next cohort? I believe we've settled on, we will start accepting applications for the next cohort on January 26th. Are we in agreement with that? We're in agreement with that. I just called it out. So January 26th, applications will start. Generally speaking, we try to accept applications for as long as we can. The last cycle, we could only accept it for like 36 hours before it was just way too many. So if you aren't already signed up for notifications and you're trying to join the cohort, again, it's a free program, so demand is kind of there. It is a global program, but Dallas is given priority for seats. I would go to DSD and sign up to be notified. You'll be notified before anyone else is. And those are the applications that we'll probably accept first, but you do have to be pretty fast in submitting it, just being honest about that. So just kind of trying to keep it transparent. The last thing that I'll kind of go to is our meetup page. If you're not with us, check us out, right? As you can see here, whoops, wrong way. We have some amazing sponsors. Usually we have 2 sponsors. We definitely have 2 sponsors tonight. So I want to give one huge shout out for the building that we are in, for the place that held our conference that didn't, they dealt with a lot of our craziness. Yum Brands, please, shout out to Yum Brands, absolutely. I genuinely cannot think of another company that would have bent over backwards the way that they have over the last several years for us. They've been committed to supporting the developer community. I think they've gone way above and beyond that. So huge shout outs to them. They're why we're here. They don't charge us for the space. They allow us to do this every 2 weeks. So huge kudos to them. The second one is Sonar. I was going to read something, but since they're here, if somebody from Sonar wants to come up real fast, Satinder, I think you want to come up and just say something real quick about them being here. Huge shout outs to Sonar, please. They're the reason why we got pizza and drinks, okay?
Awesome. Thank you so much, everyone, for coming here tonight. Thank you for the organizers for giving us this opportunity to partner and talk about coding in AI. So again, hopefully you know Sonar. If you're not familiar with Sonar, we are one of the largest integrated code security and quality platform. My name is Satinder Khasriya. I have a small talk here. I have my team here as well behind me. So Zena and Robbie, they're just waving at you guys. I'm putting them at the spot. So again, Robbie is from our solutions engineering team, and Zena is from a UX researcher. We love to partner with you developers, learn from you how we can make our product better and how we can make your life easier. So we are happy to partner here and be here. Thank you.
If people aren't familiar, what is Sonar?
So we've been in this business for about 17 years. We are the largest code quality and security platform in the world, with 7 million developers who use our product to write better and safer code. So that's what we are, and excited to be here.
All right, everybody sign up to Sonar so they give us more pizza, okay? Please. So we have 4 talks. I am going to kick things off tonight, and then normally I try to go last. Tonight, I think I'm going to go first. And Satinder will be second, Kierra third, and last but absolutely not least, Kyle Shelton from Grafana will be last, all right? Whoa, what did I just do? Okay, I hid my notes. Oh, and before I even, actually, I'll get into that in a moment. I've been doing a lot of thinking lately. I actually came up with like 4 different angles for tonight's talk, and I kept like shifting ideas. But there's one that I've been going through a lot of thought on recently. I've been reading a lot of case studies on it, among other things. And for the last 2 years, I think we've all kind of been guilty of the same workflow, right? Where, essentially you type something, right? Hold on one second. You type something in a box, you hit enter, and you kind of pray, right? And I call it prompt and praying. I don't know if you try it, but 10 out of 10 would recommend. Sometimes the AI overlords kind of smile on us a little bit, right? Where you get a perfect function. You feel like this was magic because you've typed something in, you got it back, you got back something that you wanted in a technical fashion, especially as a developer. It's kind of exciting in that regard. But if you're trying to build anything real, something that runs in production, and something that maybe at 3 a.m. you're trusting it to kind of work the way that you were hoping it would work, without you watching it, you know the truth. The magic is fragile, to say the least. It breaks on edge cases, it hallucinates, and when the inputs get messy, it's hard for it to organize itself. And I'm here to tell you that as we move into 2026, as I've been really thinking about this, the magic era of AI, it's dead. And that's probably the best thing that could happen for us, the more that I think about it, at least. Because it forces us to confront the engineering reality that we've truly been ignoring in a lot of this. We are trying to build deterministic systems, software that works the same way every time on top of the probabilistic, futuristic our foundations, models that roll dice every single time that we speak. We have spent 50 years building tools for deterministic systems, type checkers, unit tests, state machines, CI/CD pipelines. And then we threw it all out of the window because that demo looked so cool. And I think that's wrong. So tonight, we stopped doing that. And I want to show you what actual AI engineering kind of looks like. And it comes down to 4 architectural pillars. As the more that I've been thinking about it, this is kind of where I've like really honed in on. State orchestration, I think, is one of the first pillars. Second is constraint generation. And the third would be infrastructure reliability. Fourth, regression testing to a certain degree. So let's kill the magic and start actually engineering again. So when I think about state orchestration, let's start kind of there, right? With the first pillar. We all want to build agents, but the biggest mistake I'm seeing developers make is building the monolithic agent. They try to stuff history, the instructions, the reasoning, and the tools all into one context window, and they hope that the model figures it out. You're finding this to be a big issue with a lot of people. We know the context window is noisy. As it fills up and it recalls, it degrades every single time. The model gets confused over time as well as it starts dropping context in order to fit those windows. If you've used some tools like, let's say, root code or other agentic tools, you know as soon as it hits its window, magically it gets more space. Well, it doesn't magically get it. It's dropping something off. The more you do it, the more that gets dropped off. And what you started with in the beginning is no longer where you really are at the end. That's why some of these tools are trying to come out with larger context windows. But there's one thing that I don't think a lot of people talk about: context rot. They try to stuff in a lot of stuff in the history, and here's the mental model shift that you kind of need to make. The model, it's not an employee. The model is a stateless CPU. If you rely on the model to remember what step of the project it's on, you've kind of already failed at that point. In engineering terms, the pattern you need is a finite state machine, or FSM. You don't ask the LLM, what should we do next? You define the states in your code: state research, state code, state review. Your backend, the orchestrator, holds the state in Redis, Postgres, something along those lines. When you need a task done, you hydrate the context for that specific state only. You treat the LLM as a pure function: input, state context, output, action. Then you kill the process. The orchestrator persists the results. The model is just the engine. You are the driver. Senior engineers don't build smart agents. They build smart orchestrators and that manage stateless models. I think this is a very key differentiator in the way that I think a lot of people are starting to think about this a little bit. And so I want you to, like, if you harness the, if the harness is the state of the machine, what is the prompt at that point, right? I tell people all the time, stop chatting with the bot. Stop with the please, the thank yous. I'll be honest, I still say thank yous. Just when they decide to take over the world, they're going to remember I was nice. Um, could you maybe, I actually saw something very recently from Kaparchi where he was basically saying, you should stop asking the models, what do you think about this? And this really made things click for me because he said, if you do that, it assigns a persona, it assigns something from the, damn, what is the word I'm looking for? Vector database. It assigns something at random to give it the persona that it needs to be the you. Instead, you should be saying something along the lines of, what group of people would identify with XYZ? Based on that, you'll get a completely different level of result. I didn't believe it until I tried it across several different LLMs and attempts. Completely different results than what I'm normally used to. Really impressive as far as I'm concerned. In 2026, English, the way that I'm starting to think about it now, is almost a compiled language, if you really want to start thinking about it. When you write a prompt, you're writing code that compiles into a probability distribution center. Ambiguity is a syntax error at this point. There are two patterns you need to be using right now to handle this. One is pre-filling. Two is type safety for probabilities. Let's kind of jump into that a little bit. The context injection pattern is kind of what I'm thinking about this in this regard. Anthropic has an amazing engineering blog and resource, but they released a lot of case studies in there. And one was the harness case study, which I was really like diving deep into. This is where like a lot of this started coming to light as far as like the shift in mental models. Anthropic's engineering log show this pretty clearly. Do not ask the model if it can generate JSON. You append the start of the response, the opening curly brace, to the message history before the request even leaves your server. By putting that brace in the model's mouth, you bypass the, sure, here's the code, and all the preamble that we always are pretty much at this point conditioned to skip and start getting into what needs to be in there. It basically now knows it needs to fill in the rest of that JSON. By putting that brace in the model's mouth, you bypass it, and you force the model's probability distribution to align to your schema immediately. And I want to actually make a call out to this super fast now that I think about it. If you go to, this is a shameless plug for real though, Developer's Guide dot AI. Whoop, there's a comma there, right? If you go to developersguide.ai, some pretty incredible people made like a really great resource that can explain all this to you. And of those people, if this is connected to Wi-Fi, is it? Yeah. If it'll, you've blocked developersguide.ai, and the things Yum does to me, it blocks Google Slides, it blocks all this other stuff. Well, try it on your phone if you're not on Wi-Fi. Uh, but Developers Guide, I'm just going to leave it running. But developersguide.ai is a phenomenal book, and I will admit I do have bias because I'm one of the authors of the book. The secondary author is right there. Jerry over here is in the house. Jerry, absolutely. Fun fact about Jerry, he's actually led two different teams within the cohorts as well. So like constantly giving back to the community, I think that's phenomenal. But we cover a big portion of this where it's getting your responses back in structured formats. A lot of people end up missing the mark when it comes to JSON structured responses. And if you're, let's say, leveraging a chatbot and you're trying to get responses back from it, by not putting it within a JSON structure, it's really hard for your system to parse it. And it becomes even more so dang, it really did not go there, huh? Go figure. It really becomes hard to determine what you're going to get back. By putting it in that structure, you can parse it a lot easier and kind of go through it as a JSON object. Type safety for probabilities was the second thing that I was talking about. So if you're a backend dev, you wouldn't let a user input raw SQL. There's just no way that you would do that. So why are you letting an LLM output raw text? Use tools like Pandatic or Instructor to, and basically preventing a lot of those rare use cases. These hooks into the sampling loop, into your schema requires, and let's say if your schema requires an integer, for example, and the model attempts to sample, let's say a letter, the sampler rejects it and forces a resample, redoes that loop. That gives you type safety on top of a probabilistic engine. It turns it into, this usually works into it now adheres to the interface contract. One interesting thing that I just saw, Prisma, they just dropped Rust for TypeScript and JavaScript. They found it to be significantly faster, but of course, with the type safety, they're getting out of a lot of edge cases according to their reports. This kind of just goes into something that we pretty much know to a certain degree. Type safe languages often provide you a little bit of security, definitely not a lot, but it provides you more than you'd have without it. And so when I think about getting that input back, similar deterministic pattern. And so part three, infrastructure reality, right? So now you might want to say, Danny, trust the APIs, it's Google, it's OpenAI, it's solid. No, it's not. It's not at all. Anthropic dropped a post-mortem very recently that every engineer, in my opinion, needs to read. Check out their blog. I think it's phenomenal. But they traced a bug where Claude was outputting corrupted text. I found this so interesting because it wasn't just random characters. It was a random language that it was picking every single time. And it was down to the hardware failure of the TPU that it was leveraging. So specifically, an optimization for an approximate top case sample filing had a floating point precision mismatch. And the hardware literally dropped the correct token or the correct characters and responses, forcing the model to hallucinate. The interesting part was if it was outputting something in English, it was taking the lowest probable token to replace it with. And in most cases, when in regards to English, it was picking up Thai characters. And it was inputting Thai into English text because Thai had the lowest probability of actually being the accurate characters needed. Somehow, due to this bug, it was pushing it to the top. So think about that. Like we're treating these APIs like magic black boxes. They truly aren't. They are distributed systems running on experimental hardware that gets hot, it drops packets, and has bit flips. If the people building the models are dealing with corrupted sensors and tensors and issues, you cannot build your app assuming that AI will work perfectly. You need to retry back off strategies. You need fallback models. So, for example, if Claude fails, try GPT-5. If that fails, then maybe try Gemini 3 Pro, something along those lines. You need to assume the interference will fail because eventually the physics will absolutely catch up with you. It's inevitable. So regression testing, part 4, right? So finally, the most important pillar, testing. We've I work at this labs transparently, and with this we have implemented a lot of AI strategies in a lot of organizations. One of the things that we constantly look at is what's your testing system look like? Like, do you have tests here? It would be wild to kind of just let your LLM or AI agentic tooling just run wild without some kind of check and measure in place. And so if you lack that, that's often step one. Let's get some tests in place just to make sure like we're protected to a certain degree. But I look at this slightly different now. In traditional engineering, you have unit tests. So maybe like assert 2 + 2 = 4 or something along those lines. Is it equivalent to 4? Is that the output that we're getting? In AI, we have vibe checks, right? So we look at the output and we say, yeah, that looks good. That looks great. You cannot scale vibes. So as users and inputs and values grow, this doesn't necessarily scale. So in there, you need evals. You need some kind of evaluations that is regression testing for probabilities, essentially. You need a golden data set, like 100 examples of perfect inputs and outputs. Every time you merge a PR that touches a prompt, your pipeline must return back to these 100 examples as a reference point. And because you can't assert text equality, you use LLM as a judge. This is something that I think as the more I talk to people, I'm realizing like this isn't necessarily something folks are familiar with. You have let's say you have a smaller, cheaper model that grades your output. Did it follow the schema? Pass, fail. Did it hallucinate? Pass, fail. Those checks would be something that you could be that LLM as a judge reference point. If your pass rate drops from like, let's say 94% to 89%, you break the build. Don't set it forward. Even though 89 might be pretty incredible, that 5% degradation or 6% degradation would be something that I'd want to pay attention to right away. This is the only way to truly refactor prompts without fear. You stop guessing if your prompt is better and you start measuring if it's better, which I think is far more deterministic and valuable as far as I'm concerned. So I'm going to kind of allow you to think about a couple things that we've kind of gone over. And I'm just out of curiosity, show of hands, have I covered any terms that are brand new to you? Oh, everybody knew this? Okay, cool. Everyone's like, AI genius, great. Hey, where did I put one thing on notes here. Yeah, I'll leave you to this. Prompt engineer role, I'll be honest, when it came out, I think we were all kind of in the same area. Like, this is not going to be something that can stick around for too long, and it hasn't. But the way that I think about it, for example, anti-gravity. Anybody used anti-gravity yet? Very small group of people. Okay. Anti-gravity, if you're not familiar, when Gemini 3 Pro dropped, Google came out with their own version of an agentic IDE. So if you're not familiar with agentic IDEs, I'm sure you've heard of a term called Cursor. Everybody familiar with Cursor? Anti-gravity is Google's answer to Cursor, essentially. But it's taken it a completely different step forward. By the way, if you haven't tested out anti-gravity, now is kind of the time because all their LLM models have free access. So it's not just Gemini, they have Claude in there as well, completely free access right now. So you could just run with it without having to pay the way that you'd be paying on overages and other things. Obviously, this is not sustainable. They're probably just using it as a way to grab people, but you can run a lot of code right now without paying for it, essentially. But the secondary step of this is they kind of see what I'm seeing as far as how the average developer is probably going to be interacting with things. And it's going to kind of morph into what I call the AI architect role. It's not really an official AI architect, but if you look at anti-gravity, for example, in your IDE, you have the regular VS Code fork that we're all used to, like the cursors and VS Codes of the world. But the secondary part of that is you have an inbox. And it's essentially like you have a team of software engineers, and you can send 1, 2, 10, as many agents as you want on tasks. They can be very long, drawn out tasks, 20-minute, 30-minute tasks. And you'll get a message in your inbox, which is basically you code reviewing the output. That's a big time saving in certain aspects, right? So if you have a really strong style library in place, you can leverage that to kind of say, hey, we have the style library, follow this guide, build out this UI in the front end. It will reference that each time within the process and build out whatever UI tooling that you're trying to present it. I was hoping I would be done with it today, but I'm not. So probably tomorrow. I have a brand new version of my personal website going up. Everyone I've shown it to, they've gushed, they've loved it. 80% of it has been written with AI. It's not vibe coded, unfortunately, but it is AI leveraged. And so if you see the quality and the quantity of code that went into this, it's far more than what you would think a basic personal site to be. The UI, I think, is pretty phenomenal. Many tend to agree with me in this regard, but there's a lot of content in there. And by me leveraging AI, it's allowed me to really accelerate a lot of this growth and the output that what I've gotten so far. To be honest, I probably would have need maybe a team of several people to kind of hit the quality and outputs that I did. If you aren't already checking it out, there is a podcast that's pretty popular called the Programming Podcast. Shameless plug, I'm on there. We currently ranked 41 in the world for tech, so we're people tend to listen, but we covered in one of the episodes how I was utilizing cron jobs, among other things, to pull in our daily podcast, our weekly podcast episodes that we upload. Very complicated process. It actually took a ton of time. But because of AI, I was able to shave a task of days into mere hours and really kind of execute that at a high level. So I think leveraging tools like anti-gravity would be like a great way to kind of at least experience something. And especially since you don't have to pay for it right now, could be cool. But the way that I'm looking at things right now is the AI architect role is really going to evolve even more, right? And the moat isn't necessarily the model. I think we all have access to the same models at this point. Even people are saying like there's a lot of similarities between models at this point, which I think we can all agree to a certain aspect. I think there's certain things that certain models excel at compared to others. I think Gemini, if you're not familiar with, I think Gemini excels beyond belief at text, ideation, images, and video. In my personal opinion, and everyone is different, code quality is just not there. I know they're trying really hard. I don't see it at that level, unfortunately. When I look at Anthropic, I don't think there's a model that exists that comes close to the levels of code quality, architecting, and thought process. When it comes to ChatGPT or OpenAI or any of those models, I honestly used to use GPT pretty regularly. I'll be honest, it's been several weeks since I've touched it. I don't think it's at that level. OpenAI hasn't had a successful pre-training run with any other models. In fact, the last successful ones were four models on the fours. Yes. Yes. I think so. I think these models are trained on certain things, right? And with Gemini being like based off of a lot of Google data, Google having YouTube being really focused on image and video creation, it really excelled there more than anything else. It can output code, don't get me wrong. And I'll be honest with you, now that I think about this, let me add like a little asterisk. I think it's phenomenal at UI-based tasks. It's very, very good at UI-based tasks. But anything where you start getting deeper in logic, from my experience, and this is anecdotal at best because I don't have a study to prove this, besides like the benchmarks that they post themselves, it doesn't compare to the quality of output that I get from an Anthropic model, especially when we start talking about like deeper thought process and thinking. There's tons of models out there now. There's some models out of China that are pretty phenomenal. Some models out of other countries as well. It's becoming cheaper, which we all kind of knew was going to happen as well. The cost of tokens are going to continue to drop, and it's going to become far more cheaper to create really great models. It just needs time at this point. But again, the moat is not the models anymore. The moat is you, essentially. It's how you're leveraging it. It's your state machine. It's your type safety. It's your testing pipeline. Stop looking for quote unquote magic and start building the machines. Let's have a great night. All right. Satinder.
So welcome everyone again. My name is Satinder Khasriya. I'm a technical product marketing manager at Sonar. Before we jump into the slides, quick show of hands. Who here is familiar with Sonar Cube? Love it. And I just want to draw the connection because I did speak to a lot of folks and nobody knew who Sonar was. So we are the parent company for Sonar Cube. So, the topic I want to talk about today is code quality. It's just an extension of what Danny just spoke about. But before I go into code quality, I want to talk maybe get some attention to some of the recent issues, right? Everybody's familiar of the Cloudflare outage and CrowdStrike, issues that happened. And I want to remind, you guys that every security vulnerabilities is essentially a code quality issue. And think of that as we move into this age of AI, it's going to really amplify those code quality issues. So that's what, we're here to help you guys understand, decipher, and maybe share some knowledge, what we've seen with our customers. No marketing slide is incomplete or complete without having some statistics, right? I think on this slide, the key takeaway is just the sheer volume of code that's going to be written by AI-assisted tools today, right? Cursor's writing about 1 billion lines of code, per day. And, one of our recent assessments in our own in-house, we kind of analyze about 700 billion lines of code per day. So that's a huge amount of code that we analyze, and a huge amount of code is being written by AI-assisted tools to help developers move faster. This is the outcome, right? So what we're seeing is that the amount of code through AI tools is just going to grow exponentially. And there's a plateau for developers. Again, I like it because we don't have to work that hard, right? You've got AI-assisted tools helping you write code, but what it does is it leads to the biggest challenge that we are finding from our audience. So we did a survey, from our own customers, from our own developers who use a product or who use other LLMs, and only 3% of developers actually trust the code that's written by those AI-assisted models. That's a very low number, right? I don't know any other technology where that's low amount of validation still leads to that adoption, right? If it was, if you had a product that really only worked 3% of the time, you would never buy it. So I think that's what we want to understand here is that even though we're using these AI-assisted tools to generate code, ease our workload, but there's issues with that code that's being generated. There's hallucinations, it's verbose, there's security vulnerabilities that kind of creep into it. So a lot of time, is spent by developers trying to fix that code that's been written by those tools. And it takes us to the fundamental question, is the code good or bad? I want to do, just by a show of hands, how many of you guys trust the tools that you use, the models that you use? Is that code good or bad? I see, blank faces said that tells the truth, right? And this is where I think the goal here is to help you guys understand that even though we're seeing this productivity push to code faster, right? And I think this is what we call our AI productivity paradox. Most enterprises or your CISOs or CIOs are saying, we need to write faster, we need to move faster, we need to code faster so we can get new services, new features out, right? Let's use all the tools that we have. So now we've shifted the bottleneck from the developer writing code to the bottleneck being verification. There's this huge amount of code that's written. Who's going to verify it? And again, I know Danny mentioned about vibe. So you cannot vibe without verifying, right? So that's the mantra that we at Sonar are saying is that yes, you can use all these tools, but you also need to be aware of all the biases, all the inherent flaws, or the way you can use these LLM models to write better code. So what we've done is, there's tons of independent industry benchmarks, right? You can look at different reports that tell you how these LLMs are performing, what kind of code they're writing. What we decided to do, our research team said, let's just do an in-depth analysis of the top LLM models, and we'll build our own benchmark based on what we hear from our customers, what we hear from our developer community in terms of what they're looking for some guidance into using these LLMs. So, and I'll share the link. It's available online. So what we've done is we've created a leaderboard of the top 5 to 6 LLMs that are most prevalently used, right? So I want to caveat here that SonarQube, we're not sponsoring or not saying or agreeing to a particular LLM. So this is just an independent analysis of what we found of those LLMs. And in terms of the methodology, we used about 4,400 Java programming scripts to or to run across the same so that the setup was same. And so here's a quick dashboard. So I'll show you the actual site as well. But what we were able to find was through each of these models, what type of output code was delivered from these models, right? And, and let me actually switch quickly here. There we go. All right. So what you can see here is we've done an independent analysis of the 6 models here. So our approach was, let's look at the ones that are more commonly used. You don't see Gemini here. Again, there's some additional work required. And this is a publicly available link. So you guys can go, and I'll share the link later, and you can check, our methodology, how we've discovered what we are doing, what kind of tests are we running, and then the goal here is to just understand how these LLMs have their own individual personalities, how these individual LLMs behave in different type of code environment. And I'm just going to click on one to give a little bit of more insight, right? Just a quick round. I want to check with you. Who's aware of cyclomatic complexity? I think these are very common terms, but again, I'll still go over. Go ahead. You have a question? Oh, we're perfect. Yeah. So what here, we've got 2 metrics, software quality metrics that are very often used in the industry, right? So cyclomatic complexity is, how many independent paths did the LLM take, or how the code is written, right? How many and, if, or statements. So it's is it maintainable? Is it reliable, the code that's written, right? And cognitive complexity is how readable is this code to a human developer, right? In terms of its readability, right? And so you want these 2 metrics to be on the lower side. The lower the complexity levels, the better the code is, right? And those are the couple of metrics that we've calculated for all these LLM models. So again, as you can see, and I'm just going to pick an example here. This is the Claude. So 300,000 lines of code, it's pretty complex, right? And again, if you look at the LLM model, what it means is that you as a developer have to look at how this code is being written. Now, I think a couple of stats below that just catch an eye. 59% security vulnerabilities in that code. That's a huge amount of security vulnerabilities, injection flaws within the code that's being output through Claude, right? So again, this is where this is an independent verification for you guys to take a look at how these different models react. How have we as Sonar built this and be able to share this independent insights? So you can tomorrow, if there's a new model or there's a new, you can put in a request, we'll be able to give that update as well. So it's more of a benchmark saying, as you use these LLMs, you need to be aware of what kind of risks are propagating in that code. So this is, what I wanted to share with you today is SonarQube is the independent layer of verification for your code that's being not only written by you guys as first party, but also your AI-assisted code. I want to pause here. Any questions? So yeah, so if you go on that back, and I'll bring that site back. So the open source model it had the lowest range from 13,000. But if you look at Claude, it went up to 88,000. So there is no standard for us, right? The lower the better, because the model itself is trained on data provided by the owner, right? Or the company that's building it. So we can't say that, 88 is bad number, right? We want it to be lower, but in certain cases, you would accept Claude saying, here's the perfect use case for Claude because it can do X, Y, and Z things. So that's where it's essential as a development team to really look into the modalities of the LLM. What kind of code, are we writing for, Claude? Is it good for JavaScript? So that's where you have to dive a little bit more deeper into the LLMs to see if it works for your team or not. So currently, our focus is just on the LLMs. So that's where we'll have it, and it's going to be updated on a regular basis with other LLMs. We don't have plans for programming languages yet. I want to be frank with you guys. And again, this is accessible to everyone. We'll share the link later as well. I do want to do a call out, to my team in the back. So we've got, a great team. We're looking for folks to come in and give us some feedback into a proprietary app. So we're looking for feedback from developers on how they use tools and how the workflows work. So we'd love to get that feedback. And then you get your name put in a draw for a Lego set. I do want to talk, some of the takeaways, right? It's, what we're trying to show here is there are other benchmarks as well. As your engineering teams are adopting AI tools, it's essential to evaluate those benchmarks, look at the independent numbers, and then decide which model is the correct one for you. And then, oftentimes we've seen, security is the bottleneck, right? Always that. So you have to start looking at, code quality and code security as the two sides. So as soon as you can address those quality issues, means that you'll have a far lower number of security issues going into production. So that's what, we want to redefine how you look at code quality and how you look at code security. The last, we are the independent layer of verification. This is something that I was just talking to a customer recently, and you can ask your LLM the same project code, and every time it'll have a different output, right? So how can we rely on that same code to verify itself? That's why you need an independent layer of verification for your code. And that's where, SonarQube comes in, vibe and verify. That's all I had. Thank you.
Hey y'all, how you doing? Great. Hi, I am Kierra Dotson. I am an AI engineer at IBM. I also do a ton of public speaking, as well as data and AI content creation. But less about me and more about the presentation. So I have been fascinated by small language models and also edge computing. So I'm really going to show y'all more about that and what I've been doing in my research. Keep in mind, I'm an AI engineer, not an ML engineer. So I don't know all the crazy probability and statistics and all that stuff. So let's get started. So before we talk about the future of SLMs, let's acknowledge the presence with LLMs. So large language models were created with an ambitious goal of, emulating human intelligence across a broad set of domains. They're the reason you can ask ChatGPT or Claude, Gemini, whatever your flavor of choice is, about a random topic, such as, underwater basket weaving, and then also ask it to draw parallels to something completely unrelated, like something like greatest pop stars of all time. And it'll do that for you somehow. So the reason for these capabilities start with the trillions of tokens of training data that's actually sourced from all over the internet, whether that's web pages, books, or even code. By the way, most of the training data actually comes from Reddit, if y'all did not know that. But it's also private curated collections as well too, which a lot of the larger companies use. And when discussing LLMs, we have to mention the coarse transformer architecture, and that is a neural network that breaks down input, which is sentences, and weighs the relevance of all those individual words against one another. So they have given us unprecedented capabilities in complex reasoning, content generation, and even coding assistance. And it's the foundation for the current AI revolution. But this power comes with a cost in many different ways, and it's hitting a wall when we talk about ubiquitous real world deployment. And that wall is built on three different pillars: latency, cost, and privacy. So, most LLMs, especially at the enterprise and consumer level, run on cloud infrastructure of some sort, whether that is neo clouds, which are specialized cloud systems for running AI workloads, or your popular cloud services like AWS, GCP, things of that nature. And every single interaction with an LLM actually requires a round trip to a massive data center. And we've all experienced that weird wait time where we're typing something in ChatGPT or Gemini, and it takes a bit of time to respond. And after a few seconds, I know our attention span kind of shortens out, and we quickly want to switch to a new tab, or even try another chatbot assistant to see if it can respond faster. And the thing is, we're all pretty much tech savvy here, so we all understand that API calls can take some time to respond. However, as consumers, we and everybody else don't really care about that. We just want the product to work. And so that, of course, decreases customer satisfaction for the business. So there's also LLMs costing a fortune in compute. And the majority of this is due to inference, which is that response that you usually get when interacting with an LLM. So those costs rack up even more with the introduction of reasoning models, which use a ton more inference, and that makes it unsustainable at a global scale. And this is kind of obvious, not to pick on them, but we see this with OpenAPI. They're burning through money at this point just dealing with inference, especially because the majority of their users are not paid subscribers. So to paint a better picture, I did a little bit of searching on the internet. So OpenAI spent about 12 billion alone on inference compute at Azure just over the last 7 calendar quarters. And its implied revenue for that same period of time was only about 7 billion. So I don't know if y'all, I'm pretty sure y'all can do math. You're very logical people, but they're clearly not making any type of money. And then lastly, LLMs are not all that privacy friendly. So when you're sending any type of critical data to an LLM, that information is sent to the cloud system, and that creates massive compliance and security risks. And that is not really good for healthcare and finance industries. So with LLMs, we're really trading performance for centralization, and that is a bottleneck that we probably should be working on breaking. So that brings me to small language models, or SLMs. So both SLMs and LLMs, they follow similar concepts of probabilistic machine learning for the architectural design, their training, as well as data generation and model evaluation, right? So SLMs, as implied by their name, are much smaller than LLMs and typically only go up to 10 billion parameters. SLMs are also trained on data from specific domains, whereas LLMs emulate intelligence on a wider level, hence us drawing parallels between, underwater basket weaving and pop stars, whereas SLMs might only be focused on maybe healthcare or finance, depending on how they're specifically trained. So the trade-off is that SLMs are not nearly as resource intensive as LLMs, and that inference speed is actually much faster. And this also makes them much more accessible to everyday people and also just researchers that want to play around on their laptops. So again, researchers, AI devs, and other individuals can explore and experiment with those models without having to invest in multiple GPUs, which are ridiculously expensive to test out and train models. And even just getting the ones that like the little small systems from NVIDIA are still ridiculously expensive. I don't know if y'all can afford it. I can't. So actually, Patrick, he's sitting next to me. Sorry, I have to call you out, but that was too cool. He actually introduced me to something called Web GPU, and it's essentially a way for developers to run, experiment with, and even deploy AI models all within the web browser. So you can actually play around and tinker if you want to without having to invest in your own system. So the breakthrough here with SLMs is really about the rebuttal of the old scaling laws. So that's where, models were supposed to be thrown more model parameters, more compute, and more data. And the solution to that, or the effect of that, is that you were supposed to get better model performance. But we've learned with small language models that you can actually yield similar results of a model 10 times its size when they're trained well, by the way. That's a very important distinction. But also, SLMs are really good for privacy and sensitive data because it actually never leaves your device unless you actually need to send it there. But that's a whole nother architecture thing that we'd have to get into, and I'm not going to do that to y'all. So the decision to choose between an LLM and an SLM actually depends on your use case. So you'll have to factor in things such as your device size, your budget constraints, privacy regulations, and even latency requirements. All right, let's get to the technical stuff. So how do we get these small models onto a phone or even a drone? The answer actually lies in the art of model compression. So the two most critical techniques are quantization and knowledge distillation. So quantization is a technique to reduce the computational and memory cost of running inference. So you're essentially reducing the precision of a model's weights from using floating point to maybe 2 or 4 bits integers. So think of this like when you have a really big photograph that's very much high with high resolution, which would be your full size AI model, and then you're going to compress that down into a smaller JPEG file, and that's your quantized SLM. So this technique reduces that memory footprint with minimal performance loss, which is really good for devices with very low storage. And then we have the knowledge distillation. And that's where you train your student model, which is going to be your SLM, to perfectly mimic the output of a massive model, which is going to be your teacher. And that's going to be through knowledge and performance transference. So your goal is to get a small model and pick up the large model's thought process to help it with reasoning, and then also help it to predict similar outputs that it would give if you were interacting with a large language model. And while we're here, let's talk about how SLMs and edge devices shift MLOps. I have an extensive history in DevOps, so I always like to talk about this stuff, especially in a room full of engineers, especially with AI, because it's such an underbaked topic. But anywho, MLOps, that is the framework for deploying and managing machine learning models. So we're moving from a model-centric MLOps to a hardware-aware MLOps when you're dealing with small language models and edge devices. So you don't need to only focus on like versioning and deploying those models. You actually have to optimize the inference for specific hardware targets as well too, and any type of edge deployments there might be, especially if you're not in a place with a lot of secure internet or some type of network for data to be sent back and forth. So this means leveraging specialized silicon, and that is your NPUs, which is your neural processing units. You're using those for neural networks, or if you're working with Google, that's going to be your TPUs. And those are basically embedded in everything from smartphones to smart cars. All right, so let's look at a few real world examples that use IBM Granite models. I swear I'm not paid. It's just that I know their case studies very well because I work at the company. But the Granite is their small language model family. They have like about 4 of them that are the biggest ones that they typically use. But these models are made for enterprise and also really large events and sports and entertainment companies, as you'll see from the examples. So, US Open. The editorial team actually used Granite models to help with summarizing their match insights and also adding captions to video content, because that's a lot of content to get through and to add captions in manually. And that actually increased their productivity by about 300%, which is a really crazy number. And I'm sure everybody's heard of Ferrari, but they use Granite models to generate race summaries as well too. And it synthesizes telemetry, weather, and strategy data to further personalize the insights and the content that the users are getting. And they can even choose a tone of voice that the fan wants to use. And then off IBM, Microsoft, they also have their small language family, Phi. They use those a lot for some versions of Copilot. Salesforce, they also have their own small language models they use for Agentforce. And then Samsung, which kind of blew me out the, it kind of threw me off. They also invited or created a tiny language model as well too in their research department. So lots of motion going for small language models, which is really cool. Okay, now for edge AI architecture. So as we know, most language models are using the transformer architecture with that self-attention mechanism. And it's very useful, but it does have some flaws, and one of them is that mechanism. It's really good for reasoning, but it does create an efficiency bottleneck because its computational cost actually grows quadratically or exponentially with the length of the input that is given. So let's say that you are sending an input or a query to an LLM and you're saying, hey, what's the capital of France? And that's going to actually translate to like 100 tokens. It's going to take 100 squared or 10,000 computational units to process your query. Mind you, the capital is Paris. So that was a lot of computational like expenditure just for what, 5 words or five, not even 5 words, 5 letters. So that's very expensive. And then also impacts the context window limit for SLMs, which is just not all that great when you're dealing with trying to scale these. However, Liquid AI, which is a foundation model startup, they actually got started in MIT research, but they released an alternative to that called the Hyena Edge, and that is designed specifically for SLMs. So it has a multi-hybrid architecture. So it uses both self-attention and also something called the Hyena Y gated convolutions, just to help with more efficient processing. That way you're using less computation power, and that's actually quite similar. They got it around to linear scaling, which you can see in the chart here. So how that works is the gated convolutions, they look at clusters of words and sentences to actually gain context about the input. And then, which is very different compared to self-attention, which is looking at the individual words. So 2/3 of that architecture uses the gated convolutions. And then to help fill in gaps, it uses 1/3 of that attention mechanism to help fill in that. So this architecture actually responds about 30% faster and requires less memory usage. And actually, that's really good results considering that every millisecond and every milliwatt counts when you're dealing with edge computing, because most times edge computing is real time. All right, so this brings us to the future. So the first frontier is decentralization, and that's through federated learning. So federated learning essentially allows multiple different parties to collaborate on training machine learning models without sharing their raw private data with each other. So these parties could be individual smartphones, other devices, or even separate organizations like healthcare or maybe some financial services. So let's talk about how that works. It starts with that central server where there's a global model, or actual global AI model that sits. And then that server sends those model parameters, which are your weights and biases, to each of those individual healthcare clients that you see there. Um, and each client gets to train that model using its own private data, whether it's like local health records, maybe it's medicine supply inventory. And the raw data actually never leaves that organization. They don't even know the other organizations exist. So that model learns from that private data and its parameters are slightly adjusted. So each client now has their own updated local version of that model. After that, the client is then going to send that updated model with the different parameters, changes, and the weights back to that central server, but they get to keep their own raw data. That central server is going to send or receive all those different updates. In this case, it's only 3 clients, but it can be from hundreds or thousands of clients. But it will use an algorithm, typically called federated averaging, to combine all those different updates to make a single comprehensive update to that model. So it'll be new and improved. And the cool part about this is that new model is sent out to those clients again, and they'll get to do the same thing with training the model and tweaking it till they get the desired accuracy they're looking for. So this is really cool technology. I think it's a great solution for data privacy, especially and for personalization, because you're getting to allow those small models to continuously learn and adapt without having to compromise your security. So not only is this useful for hospitals, but it also can be useful for smart cars that need better driving standards that match their unique locations. Like we've heard about Waymo, how they're in different cities and states now. San Francisco is very different from Austin. Is it in Dallas yet? Oh, it's like piloting out now. Yeah, so y'all's driving standards wouldn't be the same in San Francisco or Austin. So having those SLMs would be really cool. And then also for smartphones, a lot of us have different languages and vernacular that we use. So those SLMs can actually adapt to our vernacular and then improve on autocorrect and any suggestions that they typically give us. Okay, so the second frontier is hyperlocal intelligence, and that involves combining multimodal SLMs with edge devices to unlock edge AI agents. So let's say that you are a construction worker and you have on some AR safety goggles, or maybe you're using a smartphone to understand, and you want to understand how to use some equipment that you have. So you're just going to point to your device, whether it's your goggles or your smartphones, at like whatever the equipment is, and then you'll say, "Hey, can you help me figure out how to use this?" So the model will actually use image recognition to identify what the device or the part is. It will pick up the audio from what you just asked it to do, and then it'll refer to its knowledge from the manual it was trained on, and then plus use SLMs to generate instructions for the worker. Another thing is smartphone workflows. So imagine that you have some travel information. Maybe you took a photo of your hotel reservation, and then you have a text confirmation for your flight you're supposed to take. So you might tell your phone, "Hey, organize my travel information for me," and then also maybe set all this up in my calendar. So the model will analyze the photo to extract that information. It'll analyze your text, extrapolate that information, as well as create a folder, put that in there, and then it'll use those small language model agents to actually create a workflow that'll add calendar entries for your flight and hotel for you. And it might even go the extra mile and set travel alarms for you, so you'll know when to leave the house, when to get to the airport, when to leave for the airport, so on and so forth. So, oh, that was loud. Sorry. Finally, the hardware. So this is the ultimate substrate for the future of neuromorphic computing. So traditional chips, which are your CPUs, GPUs, and even some of your smartphone processors, are based on architecture made by or coined von Neumann. So this means that your processing, which is your CPU and your GPU, and your memory, which is your RAM and storage, are completely separate from each other. So for computing, your data has to get shifted and shuttled back and forth between the memory and the processor. And that movement is actually really slow when it comes to real-time processing. And it's also very power intensive, and that consumes a lot of that chip's memory. So neuromorphic chips, they actually physically integrate the memory and processing together on one chip, and that's called in-memory computing or near-memory computing. And they say it's somewhat like the brain because the brain doesn't actually separate its memory, which is your synapses, from your processing, which is your neurons. As you see here, everything sits together in one brain. So neuromorphic chips are designed to mimic that same architecture, and that enables very low power consumption and event-driven processing. So these chips are really good for highly sparse and efficient SLMs, and are capable of pushing sorry, words are hard, IoT to the smallest sensors. So a few examples: IBM North Pole, that is a chip that they have. Lohi by Intel, I believe that's theirs. And then there's Neuron Flow as well too, by GRAI, and I believe they are a startup. So neuromorphic computing enables AI to run on milliwatts of power everywhere, making the cloud optional and not mandatory. So for a couple of use cases, let's say navigation for autonomous vehicles. It'll allow for quicker course correction and improved collision avoidance. Cybersecurity, it can help to detect unusual patterns to see if there is a security breach. And then for healthcare, analyzing medical images and processing signals from any of brain scans to test the metrical or the electrical activity in the brain. So lots can be done from those chips. Okay, so we talked about a lot today, but I really do believe that the future of AI is not just big. It's just a lot of marketing and investment in it right now, but it's also small, fast, and local. And yeah, so we've explored the difference between LLMs and SLMs. We've talked about quantization and distillation. which are compression techniques for models. We talked about edge ML ops, edge AI architecture, federated learning, multimodal SLMs, and edge AI agents, and then lastly, that neuromorphic computing. So yeah, thank you all for your time and attention. I'm open to any questions you have as long as they aren't too mathematical. Otherwise, I'm just going to redirect you somewhere else. Thank you.
Grab the mic here. Extend. No, don't extend. Just going to start mirroring. All right. Hey, everyone. How about right here? All right. Hey, everyone. Thanks, Danny, for letting me talk today. My name's Kyle. I'm an observability architect for Grafana Labs. And today I'm going to talk about observability and AI, our approach to AI, and a little bit about us as a company from a culture perspective. And then we'll get into some really cool demonstrations of how we have integrated AI into our Grafana Cloud product. So first and foremost, a little bit of background on me. I'm a former SRE DevOps engineer. I've been at Grafana Labs for a little over a year now. And one of the biggest reasons why I came was because of this right here. And this is really what separates us from the other observability vendors. And that is our big tent philosophy. We don't care where your data lives. You can host your own databases. You can use ours and take advantage of the investments that we made in R&D. Hiring half the Prometheus maintainers, those types of things. If you want to use our databases, but it doesn't matter, right? Like you get to choose your data source, and we have this big tent philosophy. We're really focused on interoperability with other platforms so that customers can leave their data where it's at and visualize it from there. It's really important, and it's, we're open source first too. That's in our DNA. Everything we build, we release open source too, and it's kind of, I was at reInvent last week, and I think my biggest takeaway was our biggest competitor is actually ourselves. So it is kind of strange, right? When I was talking, I was like, all right, do you use cloud? Do you use open source? Like, yeah, we love open source. We love your tool. We love the way your visualizations look. A little bit about the stack and what we are. Our phase one or act one products are our logs, visualizations, traces, metrics, and profiles. These are our backends. This is where a lot of our investment comes in. And if you set up a Grafana Cloud stack, you're going to get out-of-the-box managed endpoints for these, plus an OpenTelemetry endpoint. And we are all in on OpenTelemetry. If you're not familiar with OpenTelemetry, it's a open source movement that kind of decentralizes the collection and instrumentation of telemetry data for your applications. And why is that important? It keeps the vendors on their feet, right? Because now with OpenTelemetry, you have control of the agent layer, and you can kind of flip a switch and send your data to wherever. You have full control over that. You're not locked into an agent, which means you're locked into a tool. And as your data grows, your bill grows, and yeah, you're kind of stuck with, okay, now I got to spend $5 or $6 million now a year on this, 10 petabyte stack or whatever. I don't know the numbers, but yeah. And so that's the foundation of our stack. And now we've taken it a step further, and we've started to really build out more things for you as a developer to build with, right? And we have our out-of-the-box solutions, which is our application observability, our infrastructure observability. Those are going to be, dashboards out of the box. They have data source integrations. They create the custom metrics. They do a lot for you. Our app observability is like a red metrics base, so it's very opinionated. We take the Google SRE approach. Our CTO is one of the early SREs from Google. We also have our performance testing, and that's K6. And if you've never checked that out, that's really cool. We have browser testing, and you can do like different scenarios. And I have a customer that's really doing a cool, they have like a test factory. So it's like a vending machine for your unit tests and your smoke tests and all your integration tests. And so their customers, who are all the developers out in the fleet, right? I'm working with the platform engineering team. They can go in and select the specific scenarios, and they also have like a score too, so that like you have to have these amount of tests at minimum in order to get your pipelines through the door. But that's something you can do a lot of really cool stuff with K6. And then on this side of the house, we have the more operations side. So we have our incident manager, we have our on-call, and we have our SLO tool. So that's the whole stack as a whole. You also have your data collection agent. We have Alloy, which is our fork of the OpenTelemetry collector. And then, but you can use whatever if you want to use the OTel collector as well. We have 25 million users. We were ranked 13th on the cloud list. And, we're really one of the top transformative companies in the industry, I believe. We're really cool too. Like we really have a big passion for community and meetups and things like that. So we sponsored the first Commit Your Code. I'm working on next year. I know, I got you. That was my bad, but yeah, we really like giving back to the community. This is our tenets, and this is where like our North Star is headed. Our three main tenets are SaaS economics reimagined. We want to make telemetry and observability billing easier. We offer our adaptive telemetry suite, which allows you to save money on your usage. No other vendor does that. And we've also done like a lot of cool stuff with cost attribution. We have our federal cloud too. So, and then complexity simplified. That was the out of the box setup that I was talking about. We just added database observability, and I'll show you some cool integrations with that here in a second. And then on the AI side, and this is why I'm here. I believe at Grafana, our CEO got up on Observability Con and talked about the shiny object syndrome when it comes to AI and all these SaaS tools and how everybody's building like these AI agents for your CRM and all that. And we've been very intentional. I mean, we've had a LLM app for about 3 years now. We haven't really started going all in on it until recently, but we've really made it a point to develop our solutions that are useful and intentional. And so, yeah, this is what we're all about. This is where we're going. And this is, everybody in the company knows what this slide means and knows where we're headed. When we talk about actual useful AI, and I'm pretty excited to go into this, but our Grafana Assistant is like our co-pilot for Grafana Cloud. And this allows what I think most people, whenever they come to a new job or you have to onboard with all these new tools and you have to understand like even just what your stack looks like or what your service setup looks like, how many microservices are important, where your dependencies, all that. The AI assistant really helps speed up time to learn. And that's what I've found. And I was troubleshooting with one of my automotive customers, and we were trying to figure out, a CPU spike, and we ended up pulling up the AI assistant. And the AI assistant gave us like 7 other metrics what were race conditions that could have contributed to the CPU spike. And now that's cool, but like if I think about like we just solved like and gathered information for troubleshooting that probably would have taken me 30 minutes, maybe 45 at max to kind of go through and be like, all right, is this metric important? All right, well, let's see that. Did it spike? No. Did this one spike? Oh, this one did, And so it's really been helpful on that front. And like people that don't know how to use the tool or write queries, now you don't really need to. You just say, hey, show me like the metrics is for my abandoned cart, and I'll do a demo on that. And now we've actually kind of taken a step further, and this is something that just came out. And that's our incident investigations agent. And now instead of like what Danny was saying, like it's kind of like the dumb AI where you give it a prompt or you give it an input and it spits out an output. That's like the co-pilot. Now we have an agentic setup to where we go into the SLO platform and a group of agents that are specialized in different logs, metrics, traces, profiles, or whatever will go through, investigate the incident, create an executive summary, and snapshot all the interesting dashboards and give you a timeline of events. And I know when I was an SRE, I hated waking up in the morning and like your first 3 messages after you just got paged at like 3 a.m. are, hey, where's the postmortem? Where's my RCA? What happened? Why do we see this blip? And why did we lose money or whatever? I mean, I know when I worked at Verizon, that was, we would, when we'd have our outages the next morning were always fun because when you cause outages at a carrier level, it's a lot of money, And so you have to be careful there, but I'll give a little tour of that. I did want to mention that we also have an MCP server. So for the open source, if If you want to hook up Cursor and use the client and just talk to your Grafana deployment, you can. There's a ton of tools, and we keep on adding. We just added the K6 tool too, so that you can talk to your tests or create tests or do whatever. But it's really cool. Check that out. I'll have the link for that. And the last thing I want to show is just kind of a breakdown of MCP. If you're not familiar with MCP, I like this drawing because it kind of explains how to hook up with your client being your computer. If you think about MCP tools, Grafana's right there, and so, yeah. Any questions before we get into demo? All right, so I wanted to start off here, and this is our entity graph look. This is in our entity graph workbench. When you auto-instrument your app, all your services and nodes will pop up into here if you do it right. It is kind of a pain still. We're working on that, but once you auto-instrument your app, this will pop up. And the reason why I'm showing this is because if you notice right here, in this section, let's say you're a new developer or an engineer, you don't know what any of this means, you can do an analyze and kind of walk through like what conclusions should I draw from this graph, or tell me what services or nodes are causing the problems. Oh, and by the way, analyze the traces. And this is the Copilot experience. And as someone who's been an avid user and knows the languages and tools, I really see the value in this from a product owner perspective on my end, because now I really can onboard my developers real fast. I mean, like, you could know nothing about this and you just got a full breakdown of like a principal or, senior principal level developer showing you everything. It's pretty rad. And so that's the Copilot experience. I do want to get into profiles. If you're into continuous profiles, we also can do an analyzation using the Copilot on the profile itself. So if you don't really know how to read the flame graphs or want to know where like your CPU or memory dumps or whatever are, you can leverage the AI tool to do that. The biggest thing that we use AI that we've been doing for a long time is we have what's called adaptive telemetry. And behind the scenes, and I'm showing you the cardinality dashboard because we leverage this data plus your usage data, and we have a recommendation engine for metrics, logs, traces, and profiles on how they're being used. So you can set up rules to drop things that are really high cardinality that don't need to be happening, or you can relabel them, but you can also just drop things that your users are not using. And that's really cool. I like that. From a forecasting perspective, this is one of our older products, and we have forecasts that you can set up, and you've seen these kind of, plot style charts to where you see the forecasts of the metric, and if anything spikes out, you can set an alert on that for anomaly detection. Basic AI, but still very useful. And this is what has me like really excited, and I think the power of the agentic solutions. What you're looking at are full RCAs that were done by AI with no human interaction, and these are actually live like outages that happen. So let's look at this Postgres connection link, and you see we have an executive summary, hypothesis, recommendations. You can do a tree view or a timeline if you're a visual person and you just like, you're talking to your exec, you're like, hey, cart went down, no money, bad. You can use that, or you can do your timeline. And I think one of the coolest classes I got to do as an SRE was an incident manager program where we did, the postmortem style that Google does and the timeline of events and have that blameless culture. This just kind of like instills that. But, oh, and if you want to know what agents were doing what or what were used, you can do this so you can trust and verify. I think we all can kind of agree that like we're on a cutting edge of AI, but I'm still to the point where I like to trust and verify. I do trust a lot more now as these models are getting better, and I can notice like, okay, I know what tests to ask, I know how to prompt, but yeah, this is our incident investigations, and you can chat with the assistant and bring in the Copilot at any time if you need to. And the last thing I want to show is our database observability tool. And where that comes in handy is for the non-DBA guys like myself, who don't really, I've been a network person my whole career, so like anything DBA I kind of run from because I know those outages always take a lot longer. And yeah, you can integrate a helper to help you optimize or understand your query. And this is going to be really good for your DBAs so that when you're troubleshooting DB performance, you find a bad query that's doing way too many calls, you can optimize it and fix it inline. So yeah, that's what we're doing at Grafana from an AI perspective. We've been very intentional. We're very open about it. And yeah, if you sign up for a free account on grafana.com, you can leverage these tools. And we got a pretty generous free offering. A little bit about myself. Like I said, I was a DevOps engineer for Toyota Races. So when you were talking about the Ferrari stuff, I was really cool. We were doing the same stuff at Toyota with track temperature. We actually had machine learning for like radio chatter, and we can tell the mood of the driver. And it's kind of fun seeing that data. But yeah, connect with me on LinkedIn. I love the topic of observability. Big fan of open source software too. And yeah, thanks for having me out. It's been fun.